Hey, how's it going? All right, so we are now on section 3.2, part 2. Okay, so a little bit more about angles in standard position, and now we're actually also going to be referencing the unit circle, like I said, that you did back in geometry with a radius of 1. Okay, so big thing on this is that we don't normally talk about angles in degrees. Okay, we talk about them in what's called radian measures, right? It's more exact because it also has to do with the radius of the circle. So it actually gives a ratio of this. So hold on, it's ready to go. Okay, so we already know standard position, terminal ray, got that. That was in the last lesson. I also talked about making sure you pay attention to that curved line with the arrow on it to show you whether it's going counterclockwise, which is positive, or clockwise, which is a negative angle, because that actually does make a difference in your answer. Okay, so basically, the reason we talk about it in terms of radians and all that other stuff, and why this is included in what we did in 3.1 is technically angles are also periodic, right? If you graph an angle in the coordinate plane, right, it relates to some point on a circle, right, that you could draw with whatever radius you want on that coordinate plane. And you could spin all the way around the circle and get right back to that same angle again. So you're repeating those same values, right? So it's still considered a periodic type of behavior. Okay, so you can actually just keep spinning around and around in a circle, backwards or forwards, and you're going to keep hitting those same angles over and over again. Okay, so very, very important. Need you to highlight, box, star, whatever you're going to do to make sure, or put a little sticky note up in your room somewhere, something where you're going to understand, because this is how we actually show the work for this. Okay, so an angle, whatever the heck theta is, right, in this case, is the arc length, which is the length of the circle, right, that is basically created by that angle. And then it's divided by the radius of the entire circle. Okay, and we're going to do some practice on this just so you get it, but you need to remember this is how you find an angle in radian measures, right? You are looking specifically at, again, the arc length, which that arc length is always created by that angle, right? Because where it starts at the 0 and where it stops at whatever it is, that's the arc length. Okay, and that's divided by the radius of the circle. And it's given in pi measure because that's how radians, are done, because it's based on the full circumference of a circle. Okay, so it's a standard measure, and this is what we're going to be using, so no degrees. Okay, and again, it's based on the fact that the circumference of a circle is the formula is 2 pi r, right? So we can find the basically the circumference, the partial circumference, right, of any piece of that circle. And then we can also use it to find the angle that made it. So we can go back and forth between these, okay? But it is a ratio between the arc length and the radius of the circle. Okay, so let's do some practice on this. Okay, so we have an angle right here, theta, and it is a fourth of, or a quarter of a full circle, okay? And the radius is 4. So remember, it is the arc length divided by the radius, right? That's how we're going to do this. So in order to find the partial arc length, right, the partial circumference, okay, so the full circumference, 2 pi r, is going to be 2 times pi times 4, which is the radius, right? So that's 8 pi is the full circle. If I want a quarter or 1/4 of it, right, divide by 4, okay, that's 2 pi. That is literally the length of the arc. That is the arc length right there. 2 pi. Okay, so we've done the first part. We've done all that just to get the top of our ratio, the arc length, and then you just divide it by the radius. It just so happens in this case the radius and the fact that it's a quarter happen to match, but it's not a big deal. So 2 pi divided by 4 is going to be, pi over 2, which is the angle measure. Okay, that's how this is going to work if you're talking about partial circumference, right, which is arc length. All right, so let's try another one. Okay, so I want a third of a circle with a radius of 3. Okay, so start again with the full circumference. 2 pi r, it's 2 times pi times 3, which is 6 pi. I want a third of that, so that's 2 pi, right? And then I'm going to divide that by my radius, which is 3. And it's done. That's my angle. I could do the same thing with, again, changing this so the numbers don't match. I could do a quarter of a circle with a radius of 3, right? If I wanted a quarter of a circle, putting these kind of together, so a quarter of a circle with a radius of 3, again, same thing. So this would be 2 pi r, 2 times pi times 3. That's 6 pi, and I want a fourth of that. So that's divided by 4, 3 pi over 2, right? And then I would divide that again by the radius of 3. Okay, so 3 pi over 2 divided by 3, or 3 pi over 2 times 1/3 would just give me pi over 2, which again, that would be my angle measure. Okay. So the numbers don't necessarily have to match. It's still going to come out and be used the same way. Okay, so going back to what you did in geometry with a unit circle. The reason we call it a unit circle is because the radius is 1 unit, or a radius of 1. Okay, that's the only reason they call it that. Okay, so that means that whatever angle you put here, right, is going to be the same as your arc length, right, because your radius is just 1. So dividing arc length by 1 does not do anything. So if I had, let's say, an angle of pi over 4, that would be my angle. That would also be my arc length. Okay, so that's basically what that means, is because your radius is 1, that's what it does. Okay, so. All right, so, and yeah, pivotal in this unit is an understatement. I will show you some tips on how to remember at least the first quadrant, because everything is symmetrical, but you are going to have to memorize your sines and cosines and tangent values and all that kind of stuff for this. I mean, you're welcome to draw it on your notes, as far as, or rather on your scratch paper or whatever when you get to the test, but it's not something that's going to be given to you. So pivotal is an understatement of how important the unit circle is when we start solving and graphing and everything else. Okay, so onwards and upwards. So now we're just going to draw the angle, right? Draw and find the arc length and actually find the angle that gets it. Okay, so these are all, again, unit circles. So we know since it's a unit circle, that means your radius is always going to be 1. Okay, so this is the way I do it. I start off with a coordinate plane. I want a sixth of a circle. Okay, so again, not a very good circle, but if I cut an entire circle into 6 equal pieces, that means each half will be 3, right? So that is approximately there. Okay, so again, the radius is 1, right? So if the radius is 1, then 2 times pi times 1 is just 2 pi. That's your full circumference, right? Full circumference. And if you divide that by a sixth, or divide it by 6 because you want 1/6 of it, that would be your arc length, right? Since you're doing, partial of the circle. And this is where we get a change. The radius is 1, so dividing by 1 does nothing. So your arc length and your angle, again, are going to be the same thing, because dividing by 1 does nothing. Okay, so 2 full revolutions. Oh, and by the way, counterclockwise, very important. That means it was positive. 2 full revolutions in the clockwise direction. So now I'm looking at a specific negative angle. Okay, so if I'm going to go around a circle twice, backwards, basically, again, the radius is 1. So I know my full circumference is 2. And if I'm going backwards, it's just negative 4 pi. You don't have to do any more than that. Now, if you show it on the circle, oh, by the way, I forgot that one. If you show it on the circle like you're supposed to, okay, so there's my really badly drawn circle. If I'm going to show 2 full revolutions going in the negative direction, right? 1 and 2. There you go. That's 2 full revolutions in the negative direction. That's it. And it's basically anytime you see a spiral, you know you're doing more than 1 full rotation of the circle. Okay. I believe if you watch the Winter Olympics and you watch snowboarding or you watch skateboarding, they talk about 360s and 720s and 180s and all that other kind of stuff. They're talking about it in degrees. Same thought process in radians. Okay, so let's try the next one. So 3/4 of a circle in counterclockwise, so positive direction this time. All right, so again, really badly drawn circle. If I want 3/4 of the whole circle, okay, so that means I'm cutting my circle into 4 equal pieces. Boom, 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 boom. It already is. All right, so 3/4 of a circle would be, let's actually get that here. That would be my terminal side right there. Okay, so same deal as last time. Again, full circle is 2 pi because the radius is 1. So 2 pi basically times 3/4. That's all you're going to be doing. Okay, so 2 pi times 3/4 is 6 pi over 4, right? Because we multiply fractions, top, top, bottom, bottom. And then please simplify your fractions. In this case would be 3 pi over 2. All right, 7/8 of a circle in the counterclockwise. And again, badly drawn circles, but it's okay. I would cut my circle into 8 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8. And then I would go out to the 7th one. So again, there's my little curve. There's my terminal side. Okay, so again, same deal. 2 pi times 7/8 equals 14 pi over 8. Simplified would be 7 pi over 4. Okay, so again, if you remember stuff back from your unit circle from geometry, this should not be that hard. And I will go over this more in class if we need, just because there's a way that I explain it that sometimes helps. Okay, so basically, remember we talked yesterday about that really nice symmetry? Okay, and that 1 full circle is 2 pi. That means half a circle is 1 pi, right? And that would be half of a pi. And then down here, we already know that this is 3 pi over 2. We got that from example C. Okay. Again, there's a couple of ways that I do this. And again, since it's 2 pi, if we only look at these inside values, right? Just those right there. And by the way, that would also include these. Basically, I would be cutting my circle into 8 equal pieces, right? So if you imagine taking a pizza, basically, and cutting it into 8 equal pieces, okay? So each one is 1/8, which we've already proven. So 2 pi times 1/8 is 2 pi over 8 or pi over 4. So you're basically counting, right, in eighths or reduced down to fourths. So this would be 0. This would be 1/4 right here. This would be 2/4, which again reduces down to pi over 2 or simplifies. This would be 3/4. Pi would be 4/4, right? This next one would be 5/4. 6/4, which simplifies to 3 pi over 2. And then this last one would be 7/4. Again, you could also do this in eighths. 2/8, 4/8, 6/8, 8/8, 10/8, 12/8, 14/8, 16/8, because you are getting around to 2 pi. Okay, so that's just those ones in the middle. If you go to the ones on the outside, then it's like cutting a circle or a pizza or whatever you want to call it. And yeah, we're going to use these axes points again into 12 equal pieces, right? Which is, I think, the normal for where they cut pizza. Anyway, if you cut that into 12 equal chunks, each one is going to be 1/6, right? And again, you're just counting by sixths. 1/6, 2/6, which reduces down to a third, 3/6, which simplifies to a half. This would be 4/6, which reduces or simplifies down to 2/3. Okay, this would be 5/6, 6/6, right, for pi, 7/6, 8/6, which would be, again, reduced, 9/6, which simplifies down, 10/6, which would be 5 pi over 3, and 11/6. And again, this is, we'll go over this more in class if we need to. This is just a way I explain it as far as what you're basically doing to 2 pi. You're cutting it into equal chunks. Okay. And this is symmetry, very, very specific kind of symmetry for this. All right, so again, something that you did in geometry, you should have made a unit circle with the radian measures. You also probably have the degrees. We're not doing degrees. So with the radian measures, and then you probably also had the coordinates that went with it. So let's talk about those coordinates again. Okay, so we already talked about how the x value is your cosine and the y value was your sine, right? And they were both divided by the radius. Well, remember, this is a unit circle. The radius is 1. So when you're talking about these coordinates, these x and y, x is cosine and y is sine, period. Okay? And there were some very specific coordinates that you should have gotten on your unit circles. Okay, and again, this is a refresher. I know it's been a bit since geometry. Okay, so just remember, sine is y, cosine is x when you're talking about your unit circle, and that your tangent is sine divided by cosine or y divided by x. Okay, so we have this point, right? And again, I'm not worried about what the radian measure of this point is. I know it's pi over 3, but for right now, it's just 1/2, which is your x or your cosine value, and root 3, square root of 3 over 2, which is your sine value. Okay, so those are your coordinates. So the sine, again, at that angle is just square root of 3 over 2. The cosine is 1/2. And the tangent, remember, is sine divided by cosine or y divided by x. So basically, you're dividing square root of 3 over 2 divided by 1/2. Well, we don't divide by fractions, remember, and you don't need a calculator to do this. You multiply by the reciprocal, and the 2's cancel, so the tangent at that point is just the square root of 3. Okay, so there's your point P, right? So now they're going to ask you to make another point on that circle where P is your reference, right? Because everything is symmetric. Okay, so point R is taking point P and reflecting it over the y-axis. Okay, so over the y-axis means that it's going to be in quadrant 2 in the same location. So this is where R is going to be, right? So there's R, and there's the angle for R. And this point, since it's symmetric to P, right, it's just been reflected, is going to be negative 1/2 square root of 3 over 2. Just like before as far as changing the x and the y's. Okay, so I want the values for that one. So sine, still y. Okay, that's still root 3 over 2. Cosine is the x, and now it's negative because you reflected it. And the tangent, because you're dividing sine by cosine, you're going to get the same answer. It's just now going to be negative root 3. And that is it for this one. Like I said, we're just getting back into that unit circle, and we'll talk more about it in class if we need to.